Here we have the sum of n equals 1 to infinity of x minus 2 to the power n over n to the power n. And we want to find out the radius of this and the interval of convergence. We're going to set up our ratio test for this. So we have the limit as n approaches infinity. And we're going to have our n plus 1 term. So it looks like this, x minus 2 to the power n plus 1 over n plus 1 to the power n plus 1. And then we're going to have our n term in the denominator. So x minus 2 over n to the power n. And we want to know where this is less than 1. So we want to rearrange this. So we end up with the limit as n approaches infinity. And we're going to group some of these terms. So I'm going to have my x minus 2 to the power n, and then I'm going to write that as x minus 2, that's my plus 1, that's my n plus 1, so maybe I'll highlight that, that plus 1 shows up here, and then I'm going to end up with, in the denominator, x minus 2 to the power n. Okay, that's going to be all grouped together. Okay, you can see that some parts cancel out there. The n plus 1, so the n terms or the sequence terms are going to then be grouped together. So it looks like this. I end up with n to the power n, and I end up with n plus 1 to the power n plus 1. So I'm just going to write that as power n, and then an extra n plus 1. And again, the plus 1, that plus 1 is showing up. This plus 1 is showing up as that factor there. Okay, and we want that less than 1. Now, some terms are going to cancel out here, and I can group some terms. I'm going to group this term here. Okay, and we can cancel out some terms in here. So these are going to cancel out. I'm going to be left with the limit as n approaches infinity. I'm going to be left with a factor of x minus 2. This n to the power n plus 1 to the power n, I'm going to rewrite that as n over n plus 1. That's all to the power n. Now, we can kind of predict what's going to happen here. We're going to let the n over n plus 1 go to infinity. That is just basically 1. 1 to the power infinity, n is going to just be 1. So that blue term is just going to be 1. And then we have the last term here, which I'm going to group here. Maybe I'll draw this in. I'll do that in green. So we're going to end up with that 1 over n plus 1. And that needs to be less than 1. Okay, so then evaluating this, we're going to end up with, when I plug this in, I apply my limit, I have my x minus 2, that becomes 1 to the power infinity, which is just 1, and then this becomes 1 over n goes to infinity, so infinity plus 1 is infinity. So that factor is going to end up being equal to 0, and that's less than 1. So what we end up having here is this x minus 2, and I'm just going to keep that times the 1 divided by infinity as a times 0. Okay, and then that needs to be less than 1, and that's going to be greater than negative 1. Well, what x's will satisfy this? Well, any number that I put in here for x, since I'm going to multiply by 0, it's going to be bigger than negative 1 and less than 1. So x in this case is going to be all real numbers. Now we could show it we can also show this, and this is unnecessary, but we can show it like this. We can say that x minus 2, and then we can divide by 0. Okay, so this is going to be 0 plus, and this is 0 plus, and we end up with our center. Our center is going to be at x equals 2. Our radius in this case is going to work out to be x minus 2 is bigger than, less than infinity, and greater than negative infinity. So there's my interval. So that means my radius is equal to infinity. So my interval is all real numbers for x. X will converge for all real numbers. Doesn't matter what we have, because that we end up with that times by 0. Regardless of what x is, it's going to stay between negative 1 and 1. And we can write our interval like this as well, from negative infinity to positive infinity, as we need to keep it open because we can't make it equal to infinity.